chemistry. And so in our chemistry lecture today, we're going to be looking at various topics. First of all, I want us to understand that this is senior secondary school 1. Okay, so chemistry, second term, that's what we're going to be looking at. Now, some of the topics we're looking at, just a summary of it on the screen. We have mole concept, we have chemical equations, we have stoichiometry, we have chemical laws, we have bonding, we have gas laws. Okay, so now let's get into the meat of the day. So now, introduction. In our scheme of work, we have week 1, introduction to mole concepts, where we have molar volume, Avogadro's number, percentage element in compound. Week 2, we have writing and balancing chemical equations. Week 3, still in that week 2 and into week 3, we'll be looking at stoichiometry of reactions, where we have masses of reactants and products, reacting gas volumes, empirical and molecular formula. Then in week 4 to 5, we'll be looking at chemical laws, under which we have conservation of mass, constant composition, multiple proportion. And then in week 6 to 7, we have still on chemical, we have chemical combinations, we have electrovalent bond, we have covalent bond, and we have other types of bonding. And then we have weeks 8 to 9, where we'll be looking at kinetic theory of matter and gas laws. And the gas laws include Boyle's law, Charles law, ideal gas equation, and Dalton's law. Then week 10, we have Avogadro's law, Gay-Lussac's law of combining volumes, Graham's law of diffusion. Now, the first topic we have here, introduction to the mole concepts. Introduction to the mole concept. Now, introduction to the mole concept, we're looking at what is a mole. What is a mole? Here we said a mole is the amount of a substance containing 6.02 times 10 to the power of 23 elementary particles. And what are the elementary particles? We have atoms, we have ions, we have molecules, we have electrons. Now, when we talk about mole is basically concerned with the amount of particles present in a substance. That's what mole is basically concerned with, the amount of what? Particles present in a substance. Or you could actually say mole is a measure of that substance. Now, each mole contains 6.02 times 10 to the power of 23 atoms, like you can see on the screen. 6.02 times 10 to the power of 23 atoms. Now, let's use an illustration, a real life situation. When you go to buy rice, and then when you get there, you tell them, I want to buy rice. Now, the first thing they will ask you is, how much rice do you want to buy? Are you getting it now? How much rice? So, basically, what they're asking you is, how many moles of rice do you want to buy? Then you reply them with, okay, you want 1 rubber of rice. You don't tell them you want 1 grain of rice. 1 grain of rice is not a measure of rice. So you tell them you want 1 rubber. So the rubber is more like a mole. So 1 rubber is 1 mole. Are you getting it now? So mole is concerned with a measure of the substance. And in 1 mole of a substance, we have 6.02 times 10 to the power of 23 particles. Just like in 1 rubber of rice, we have several grains. We have much grains that cannot be counted. Are you getting it now? So it means that a mole can be likened to a rubber. That's why we said a mole is the measure of a substance. Alright, now having looked at that, still moving forward. Now we have what we call relative atomic and molecular mass, as you can see on the screen. Now, what is relative atomic mass? We have the number of times the average mass of 1 atom of an element is heavier than 1/12 the mass of 1 atom of carbon-12. It has no units. Now, hold on, let's explain this. Relative atomic mass. relative atomic mass. Now let's look at it bit by bit. Mass is actually what? The particles that is contained in the substance. The particles that makes up the substance. So, atom, atomic mass, is the particles that make up an atom of a substance. The particles that makes up an atom of a substance. Remember, atom is the smallest part of an element which can exist on its own and can take part in any chemical reaction. Is it not so? That means when you take hydrogen now, the smallest part of hydrogen is what? The atom. Now we are now saying relative atomic mass. Relative atomic mass are the particles that make up that smallest part of what? Hydrogen. That's relative atomic mass. But now you now have the word relative. That is, what we are basically doing now is that we are comparing the particles that make up that smallest part of hydrogen to 1/12, 1/12 of the smallest part of carbon. Of the smallest part of carbon. That's how we call it relative. When you say relative, that means you take one thing and you compare it to what? Another, so as to get an accurate what? Value. So relative atomic mass is comparing the mass of one particle whose mass is not known to the mass of another particle whose mass is known. But you are not comparing to the whole of the mass, so you are comparing to 1/12, 1/12. Are we following now? So, just as relative atomic mass is to atom, relative molecular mass is to what? Molecule. And as we all know, molecule is actually what? A group of atoms combining what? Different atoms. So now, in relative molecular mass, we are actually looking at the particles that makes up what? A compound. Okay? In relative atomic mass, we are looking at the particles that makes up what? An element. But in relative molecular mass, we are looking at the particles that makes up what? A compound or a radical. Are we following now? Okay. Now, how do we calculate the relative molecular mass? The relative molecular mass. Now, since relative molecular mass is that we are looking at the particles that make up a compound, and a compound is a group of atoms. That means we need to take note of the relative atomic mass of each of those elements that make up that compound, which is a molecule. When we take note of them, we add them up together to get the relative molecular mass of that what?